Just start recording. Yeah. Yesterday we saw how simple functions are defined, and also we saw how function literals are defined. Function literals are nothing but everything except the name of the function. It is also called sometimes anonymous function. Anonymous functions are something that you use in Python, which are called as lambda expressions. So it's the same thing. Then we saw how those function literals can be used for higher order functions. And we saw again how higher order functions can be brought down to something like just passing a logic, making it more and more compact. In most of the Scala and Spark code, we will be writing the code in a more compact way. That was the main use case of higher order function, drastically reduce the number of lines of code and do not repeat the code again and again. Finally, we saw how functions were returned from a function, and we saw how type parameters were used. Sometimes we want to dynamically return some value. So in that case, we saw how type parameters were used so that based on the logic that you are passing, it could return either integer, or it could return a boolean, or it could return a double. We used a type parameter for those things. Let's move ahead. I think we have covered all these things. Yeah, here we are passing multiple parameters as well. Earlier we saw passing two parameters, we can pass any number of parameters. That is also a valid example and have such kind of operations. Not only we can pass two parameters, any number of parameters. If we are passing a function, that function can also take any number of parameters because it's simple function. There is one more thing that is called as partially applied function. Partially applied function is nothing but it is also it's called you call a function but you don't pass all the arguments of the function. That's what. And we hold back certain parameters of the function. When you call a function but do not pass all parameters of the function. This is called partially, the name itself says partially applied. We are only applying or we don't apply at all. We are only applying few parameters or we don't pass any parameters at all. So that's what is called a partially applied function. What will happen is whenever we call a function and we don't pass all the parameters of that function, it will return a function object. We know what is a function object. It returns a function object. Function object means it is a just like a function which takes parameters and returns a value. That function object will take the rest of the parameters we are about to pass. This function may take two parameters. It may take two parameters a comma b, but when we call this function we only pass a. We don't pass a at all, b at all. So it will return a function object. This function object will now take b as the parameter and it will return whatever was the earlier return value. So let's see, we have a function we can make use of that. I will define a function called factor. I'm defining a simple function called factor of x and y, and I'm checking whether x is a factor of y. That means whether 2 divides 4, 2 divides 6, 2 divides 8, 2 divides 10. Similarly, 3 divides 9, 3 divides 21. 3 is a factor of 21, we can say. 2 is a factor of 10, we can say. We are just trying to find out whether x is a factor of 2. I can say, I can call this function and I can say 2 comma 10. It will return true because 2 is a factor of 10. 2 divides 10. If I say 2 comma 9, it returns false because 2 is not a factor of 9. But what is a partially applied function here? Partially, as I said, when I call this function, I don't pass all the parameters. I will just say underscore and the type of the parameter. This is the syntax actually. This is the syntax for not passing a parameter when calling a function. Just place an underscore and specify the data type. Here what will happen, let's see. If you see, it returned a function object. It returned a function object, and that function object says it takes an integer and returns a boolean. It is nothing but the remaining parameter. The second parameter is should be used to call that function, and as usual it will return a boolean. So it is stored in the compiler generated identifier. It is stored in compiler generated identifier. I can say res2. I can pass 10 here. So it will return true because the first parameter is 2. Now I am passing the second parameter. It will check whether 2 is a factor of 10 and it returns true. So this is how we use a partially applied function. So what is the use of partially applied function? As we know that it returns a function object, we can use it for any purpose. We can return it from a function, and based on some condition we can return that function object, and that could be used anywhere. And also the code could be reused with function object. We can reuse the code with function object. Let's say how we can reuse. We have this. I will rewrite this. I will say val is even equal to, I will say factor, I will say 2 comma underscore, and I will say int. Factor of. So here if you see, the return object we have stored in an is even identifier. Is even identifier. Obviously it becomes more readable now. More readable if I say is even 10. It says that we are checking whether 10 is even or not, and it returns true. I can say 12 or 1. It returns false. Obviously 1 is not a even. So we can derive some more functions from the existing function. We are reusing the factor of function to get a is even function. That is also one more use case of partially applied function because it returns one more function. That one more function could be used for any other purpose. Basically it is reusing the existing function and getting a new function. Similarly, if I want to check is odd, not odd, is multiple of 3, we can say. Val is equal to, I will say, factor here. I will say pass 3 as the first parameter instead of 2, and I will say int as the second parameter. Okay, always off. Again, second parameter I am not passing, but the first parameter I am passing 2 instead of 3. So I can use this again, is multiple of 3, and I can pass 5 here, it will return false. If I pass 21 here, it should return true. So we are reusing the factor of function to get new functions. So reusability is one of the use case of the partially applied function. It is a, but we can also, I hope the partially applied function concept was clear here. Any questions on partially applied functions? If there are no questions, we can also say that factor can be also defined as a currying function. We know what is a currying function. Currying is nothing but multiple parameter group. It is a multiple parameter group. And this is how that multiple parameter group works. This is how we define a multiple parameter. And if I want to get a partially applied function from this function, it is, the syntax is much easier. Is even, I will say, factor of, I will only pass 2, rest I will just say underscore. The syntax is much easier in this case. You have to just specify an underscore here. So it will return a function object and I can use it as used before. Is even true, it returns false. I hope the things were clear here on partially applied function and the use of partially applied function. Any questions here? Any questions? Harsha, Karnakar, Naresh, Raghu, Ram, Naresh. Okay. Yeah, Sharat, Sukesh. Yeah, keeping these in, okay. Yeah, calling, invoking function literals with block of, with literal blocks. Literal blocks means, what I'm trying to say here is, suppose I define a function in this fashion. I will say def string. The question here is, what is the benefit of currying? Ram, you need to hold on to that question, because yesterday or day before yesterday I said that we have to still learn the concept of, okay, currying. We already learned the concept of higher order function, right? Similarly, there is one more concept called implicits. So the currying is used with those kind of functions. First, one parameter group may contain all normal integers. One more parameter group may contain all the function parameters. Internally, I don't think so any benefit comes out of currying. It is only separating the parameters. Just like I could have string ops. First will be strings, simple parameters. I will say S2 or D. Excuse me. Excuse me. D double, and the other parameter groups I can say something. And it is just like in this fashion. Just to give a separate differentiation. So first parameter group will contain normal parameters. The second parameter group will contain all the function parameters. So usually this is where the currying will be used. I have seen a lot of functions which use the currying for these fashions. Separate normal parameters with the function parameters. Function normal parameters with the implicit parameters. We have to learn one more concept called implicit. Otherwise, internally there is nothing difference. It's the same implementation we will do where we will do in the normal function, the implementation wise everything remains the same. There is no change in that. Only thing is we are differentiating certain parameters for readability purpose. I hope so. So here what I was discussing now, I was discussing about, yeah, I will say define string ops or operations. I will have x as integer, y again integer, and I will pass a function which takes int comma int, and it returns a int, and the definition of this function is just call the parameter that we have passed, the function parameter we have passed. This is the definition of the function. But I can write, earlier cases we saw that we had only simple expression. Our earlier cases were like I had defined sum which takes x int, it takes y int, and it is equal to x plus y. In earlier cases we had only single expression, single line of expression, which could have been replaced in that form. We defined, when we called operations, it said we could have used x comma y, and we said x plus y. For the parameters, we said this. Here it was only a single parameter, but suppose most of the time your function may be literal, lot of lines of codes will be there. Not a single expression, a block of expressions will be there in your function. So how do we deal with those block of expressions in higher order functions. Earlier we just saw that we could have done underscore plus underscore. We could have done only this because we had a single expression. Imagine we had multiple expression. I can say I have a multiple expression here. Just for val a I will say equal to x star 2. I will say val b is equal to y star 2. Then I will define a function x x star y. Sorry, my mistake. A star b. This is my function. This is my function. If you see, this also takes two integers and it returns an integer which matches our function. Which matches our function. This also takes two parameters which is integer and it also returns an integer. There is a match in both the cases. But here it has a block of expressions, multiple expressions instead of a single line. So how we can call? I can call this function in this. Sorry. When I call operations functions, I can say 4, 5 and I can pass some. This is a common way of doing that. But we have also seen the shortcut ways which are more used. Just passing the logic. Just passing the logic. The same thing applies here also. I can just take the literal of the function. Just take the literal of the function and place it here. Just take the literal of the function. Only thing is you have to replace this equal to mark with the arrow mark. So these kinds of also code you will see in the Scala or Spark application. Not this is also a valid syntax. Earlier we had only single expressions. This is a block of expressions. So we can check out this whether it is correct or not. I will just copy this code and paste it here. This is our higher order function. This is our another definition function which we want to pass as a parameter. This is where we are calling the function. First we'll try to call operations with 4, 5 and I will pass some method, sorry, some function. It gives me the correct result. Whatever we pass 4 into 2 will be done first. 8, 5 into 2 will be done next. 10, then 8 into 10 will be done 80. It has to return 80. But as I said, I need not define a function. I can directly use the literal of the function here and it should work. Here the only thing difference is underscore is not used here. Underscore is not used. We have to specify the parameters. Only if it is a single expression, underscores work, but here it does not work. We have to specify the expressions. So it's the same way you will be seeing such lines of code in Scala and Spark. Just to understand what is this lines of code. I hope this multiple function being called with block of expression is also clear. And
Pramod,
yeah, Ram.
uh, Here in operations, we are passing 4 and 5 as two parameters.
Right,
And
right.
instead of this, if we pass 3, then how the next function will take 2 only. Out of these 3, how it can take 2? We can pass 3
Any
integers in operations
yeah,
first.
any number of parameters we can pass. It's not mandatory that
Yes.
we have to pass the same parameters. Let me redefine this function. Yeah, this is the function. The function definition, what I will say here is it will be different. The function definition, what I will do here, I will not, as per yours, I will take z integer. I will say it only takes int. It is only the signature of the function. Only the signature of the function what it takes. Inside this definition itself, I can have multiple other things. I can say val x equal to, sorry, m equal to a plus 2, val n equal to b plus 2. Then here I can call the function that I am passing. Or sorry, val o equal to a plus b plus z, I can say, or m plus n plus the third parameter. I can just say here whatever I want to pass. It has to just take two parameters. I can pass O and N. I'm calling this function here. Not necessary that it has to be the last statement in expression here. But I have already entered it. Yeah, it is now O and N instead of X and Y. Earlier we had passing X and Y because both were integers. This time I am passing O and N as the parameter. O and N as the parameter here. What did I do? Not found value A. Oh, that that's what Karunakar was trying to say.
Yes,
Okay,
yes.
okay, okay. My mistake. I'll redefine this function. I'll define x plus 2, y plus 2. This time I will say val O equal to n plus m plus z. The third parameter also I'm using. I'll say val p equal to f of, I will say O comma n, and this I will say val q equal to p star to anything I can do here. Any kind of a function. That function is being called somewhere inside the function. This function is being called somewhere inside this definition of the function. Not necessary that it has to be the first expression. Not necessary that it has to be the last expression. If it is the last, whatever is returned from that will be actually returned from the higher order function. If it is in between, I can reuse that return function and do something else on top of that and again give the result. So here I can just say operations. I will say 2 comma 3 comma 4. Then I will say underscore plus underscore. That's all. Because addition will take two parameters and returns a parameter, returns an integer. two integers, and also it returns an integer. My mistake, because the last expression has to be, we have to return something. I will just return q here. Just return q. Now I will call the function. So this time I should get the result. So every time we were passing to this function the parameter that was being passed here itself. It is not a mandatory option. You can pass any parameter here. Only thing is it has to match the data type. It has to match the data type. And need not be, it has to be the first. Only one expression in this body. We can have any number of expressions in this body also. And it could be somewhere in the middle this function can be called. Whichever function we are passing as a parameter, it can be called anywhere inside the function. I hope Ram, you got it. Okay. Yeah, this is how we have block of literals, or we can say multiple expressions in the higher order function, as well as the function that is being passed as a parameter. Both these things can contain multiple lines of code. Nothing is stopping from writing such functions. Keeping this in mind, let's move to the next examples. There are the same examples have been given with some other code. That's all. Block of literals being passed as a parameter to a function. So I hope things are clear here. Next we'll move on to higher order function. Sorry, collections. After collections, we'll see during learning, while learning collections, we'll see how to apply these higher order functions on collections, because that's the most important thing to be learned in Scala, or not just for Scala, because the same concepts are being used on Spark also. We have a collection. On top of collection, we call higher order functions. So this is a very important concept. Means the data inside the collection, we will be applying the higher order functions on those data. If you see Spark also, it's the same thing. It has the data set. Data set we can assume just like a collection of some data. On those collections of data, we will be applying higher order function to transform the data from one form to another form. We'll see that. I'm just going ahead here. Let's not worry about that. I just want to say that we can assume the way data is represented in Spark is just like a collection. Just like a collection. But there are certain differences that we'll cover when we start with Spark. So here what are at a higher level, we have these collections, sequences, sets, and maps. Range is also a collection. Vector also we saw already, where we use the for with yield parameters. Sorry, for with yield. We used for with yield, it returned a vector. So that is also a collection. List is one of the collection. I can just say list here. vector here. These are all collections in Scala. And as I said earlier, collections are immutable by default in Scala. And we know the benefits of immutable. That's the reason collections are made as immutable in Scala. What we mean by immutable again, if you have a collection and if you try to modify that collection, a new collection gets created, the original collection remains the same. That's the use of immutability. That's what we mean by immutability. Let's take a simple example of collection here. Let's say val, I will say nums equal to list of, I will say 5, 6, 7, 8, 9. This is how I create a collection, a bit different as compared to other programming language. Here we are using just open bracket and close bracket. Nothing else is required. We don't have to again specify the data type at all. The data type is automatically inferred by the compiler as it inferred for simple data types. Even for collection, it has inferred the data type. It has said that it is a collection of integer or it's a list of integer based on what value is stored inside the list. If I say colors equal to list of 1, blue, I will say red, I will say yellow, I will say green. So again, if you see, the data type of this collection was automatically inferred as a string. Here it was a int collection of integer and here is a collection of string. So we don't have to specify anything here because the compiler will automatically infer the schema for you, infer the data type for you. So if you want, this is how we create a list. If you want to access a list, we will just say again open bracket close bracket 0th element. We'll get the 5. I will say colors of 3 will get the green element. So this is how we access an element. In other cases, how we used to access an element? In other programming language, usually how do we access a element of a collection? We actually use square brackets, get index, or we usually use in this fashion. We usually use in this fashion. But we don't use such things in Scala. Where do we use our square brackets? We use somewhere else the square brackets.
Type parameters.
Yeah, we do use it in the type parameters. We use it in the type parameters and we don't use in. Uh, yes, Harsha? Okay, you're saying Python also uses the same uh,
Yeah.
parameters, normal open bracket and close bracket. Okay. And again, but here actually it is the function that is being called. It is actually the function. There is a function called apply method. That apply method is being called here. It is not a indexing. List is not a indexing. Actually is a function that is being called here to which will pass the index and it will return the value. The same thing holds good for colors also. It is not a actual indexing, but a function is being called here. That function is apply method. And apply method, the concept is, there is no new concept here in the apply method. It is a normally as usual any other method in a class. In a class we can have multiple methods. Here also we can define multiple apply methods with different number of parameters or different types of parameters. The only property of apply method is you need not call it by name. We can just pass the parameters. We can just pass the parameters. What I mean here is, suppose I define a class A, and I say I will define an apply method here, and it takes x as an integer, and it says x star 2. Just for, I will define one more apply method here, and it takes int y comma int, and it will say x star y. So if I define a function class like this, and I when create an object of this class, val a equal to new a, I can call a of 2. I can call a of 2 comma 4. Means there are apply methods defined inside the class that will be called internally when I call this. This will call internally this function, this method. This will call internally this method, because it matches two parameters here. This matches single parameter, and we have a method for single parameter, and we have a method for two parameters. So this is what we call as a apply method. It is just like any other method in a class. Nothing new things are, no new concept is there, but only thing is we need not call it by name. It's a simple change. We need not call it by name, but we get a lot of good consequences or good results from these things. We'll see those things when we go forward, like how apply method can be used for factory design patterns. But as of now, you can think of it like we need not call it by the name. That's all. But we can define however you want, you can define an apply method. I hope the apply method thing was the concept was clear, but we'll see the use case going forward. This itself is one of the use case. This itself is one of the use case. Accessing the element of a collection. In fact, it is a list collection. So how actually a list collection is looks like? How actually a list collection? So it is actually implemented internally as a single linked list. Here we'll have 5, and we have a pointer to the next element or reference to the next element in this fashion. And the last element will be nil or empty. Either it is represented nil or it is represented as a empty list. So this is how a list is implemented internally in Scala. When we give list of 5, 6, 7, 8, 9, internally it is represented as a single linked list. Suppose you want to access element 8, we have to traverse from first to element 8. Similarly, if there are 50 elements in the collections, if you want to access 30th element. If I want to access 30th element, I have to start from the first element and go to the 30th element. If I want to access 40th element, I have to start from the first element and go to the 40th element. If I have to access some other 12th element, I have to again start from the first element and go to the 12th element. So it is a linearly we have to traverse. We have to traverse in a linear fashion. In a linear fashion. So it is not good for random access. We are randomly access 30th element, I'm accessing 40th element, and I'm accessing 12th element. Every time it is doing a traversal from the first element to the destination element. So there is a linear traversal in the list collection. Hence it is not good for random access of the elements in the collection. So it comes under a sequence. There is a sequence as one of the class, parent class of collections. Underneath we have linear sequence. Inside that linear sequence we have list actually. Similarly, there is a indexed sequence. Similarly, there is an indexed sequence and underneath it has a vector. It means vectors are indexed. Lists are not indexed. Actually, it is a single linked list. What we mean by indexed is it, it is in the contiguous memory location. The memory location is indexed there. In this fashion, the data will be stored contiguously. Here we have 0, 1, 2, 3, 4. It is like a primary key we can say. It is indexed. We get the data at the speed of constant order of C. Any data you access, it's a constant access. But any data you access in a list, it is of the order of n. So hence it is not good for random access. Index sequence are good for random access and vector is the one which is implemented as an indexed sequence. So let's see how the vector is implemented. We have seen with the for with yield, it returned a vector. It returned a indexed sequence. What we mean here is vector is implemented as a contiguous elements, 32 elements. Continuous array of 32 elements we can say. "32 elements are there. If the number of elements increases, what it does is it will create such type of a structure again here. It will create one more 32 element 32 element array. It will create one more 32 element array. I will say 32 elements, and it will keep on doing such things. Where here this will be pointing to this first 32 elements. Here we'll have a reference to this 32 elements. Here we'll have a reference to this 32 elements. Here to this and to this. So even if this gets filled, even if the data gets filled, it will be again one more level of array, 32 elements array will be created. If you see, it looks like a tree structure. It looks like a tree structure. Suppose I want to access 100th element in this case now. 100th element in this case. Here there are 32 elements, here 32 elements, here 32 elements. 32, 32, 32, we got 96, excuse me, 96 elements. 97th will be here, 98th, 99, and we'll have 100 here. Our 100th element will be here now. So how do we access? Accessing the index, I said, is of the constant time. It is a contiguous memory, and we'll just be giving the location here, and we'll get this reference. From this reference, we'll
Yeah,
move
yeah,
to,
Pramod, I have a small doubt here.
yeah, yeah,
First, first set contains 32, right?
yes,
32,
yes.
second one 32, and the 100th element will be in down the line third set, right? In the third set, it will be.
No, no. When 32 is there, right? Initially, if it is less than 32, if the number of elements
Okay,
is less than 32, this will be filled. It will be stored here itself. When number of
okay,
elements gets more than 32,
okay.
so
Only
these
that.
will contain references. Actual data will be
Okay,
contained here.
okay, okay. Thanks.
Actual data will be contained here. And I am not sure why they have chosen 32 elements. Probably some magic number. Right. So the first 32 elements will only have references when the number of data increases. When the number of data increases. Again, if the number of data again increases, which cannot be held at the second level, again it will be created here. Probably then again this will contain references to the next 32 sets of 32 elements. It will keep on doing in this fashion. So now if
So
you
if
want
that is the case, so can we add elements to the existing vector? Is it possible?
existing vector, so actually what happens, a new vector gets created.
Yeah, so that reference will be created in the above structure.
uh, Let me imagine that. So you want to add internally. We usually don't modify the immute because it is immutable. It is not recommended to add in between. We usually add using the array list or mutable array list buffer, array buffers. We internally add using these things. Finally, we can convert into a vector that could be used. But usually we keep on adding at the end. But here if you say, if you want to add in the between, uh, let me check whether we can, their APIs exist or not. Usually they won't support APIs for such things. Let's take list itself. Even list is also immutable, right? I remember it doing for somebody else. I didn't see any in between adding. Insert kind of a, there is nothing like insert here because it is used for usually transformations. There is nothing like insert here.
Yeah,
Very,
Pramod, here I have a small doubt here again.
yeah,
So here we have a list of methods to be applied on this list or any object, right?
right.
Can you go to that? Can you go to that
Yes,
black screen? Yeah. Say for example, second, third combinations. This is the method, right?
right, right.
Yeah. So if I want to know the syntax for that method or how I can apply that method on any object, how can I?
One thing is when you are using IntelliJ or some IDE, you have to
Okay.
just You have to just call that function, you will get the syntax. On the collection you have to call that, but here you can also specify combinations and just press a tab here.
Okay.
So it takes an integer and it returns an iterator. As of now we don't know
Okay.
what
Okay.
actually it does.
Okay.
We can go and check in the IntelliJ because we have to hover on that and click on that. We will get the definition and we'll get to know what is the definition of combination. Otherwise, if you want to know the syntax, just press a tab, you'll get the syntax on the REPL.
Okay. Okay. Okay.
But as
Okay.
per your
Thank.
previous question, usually we don't add an element in between for immutable collections. It is mostly used for transformations, for ETL kind of process, for transformation where we transform, we'll go through each element, transform the data to some other format. If you see here, they don't even give the APIs to add an element inside a collection, in between the collection. There is no API such like that. Apply this compose doesn't seems to be. Usually it will be insert. Usually it will be insert. There is nothing like insert here, add or add here. There is nothing like add or insert. If I take val a equal to array of 5, 6, 7, when I say a dot apply length update, there is an update method. Sorry, IntelliJ has come up. There is an update method that can be added. There is similarly val ab equal to, I will say, array buffer. What is that? Array buffer, array list buffer. Sorry, something was there. I don't remember. Those are all mutable things. So whenever we have a mutable things, right, mutable collections, we usually have APIs to modify those things. This is not the one. I think I have written it somewhere. I just wanted to show that. Class parameters, extract implicit objects, update list. Yeah. List buffer. So this is how we specify a list buffer. So when you add new things, it will be added here, appended here. Insert is also there if you see list buffer. So these are mutable things in Scala. These are all not immutable things. Whenever you are using an immutable things, you don't usually give a method to insert something in between because it will be very inefficient. We have to restructure the whole things. We have to restructure the whole things. It is usually we don't, because most of the time it will be used, take each element, transform it to something. When we see that higher order functions being applied on collections like immutable collections, those things will be clear. We don't have like insert in our vector method. We don't have the same insert method in the list also, because they are all immutable, and usually we don't recommend to add an element in between. So again, internally, when we, even if you go and add it, probably there is some other kind of a, like if you see, there is a patch. There is a patch on list. So nobody knows that patch will do. Actually, we can update something inside. Patch is a one one API on the collection that that can be used to write something, write in between, update in between the collection. But usually we don't do that because lists are immutable. It is a very, I can say, not so efficient way of modifying that. If you do it, try to use the mutable things and finally convert it into a to list, to immutable things, or to vector. Finally convert into a vector. Do all the internal modification, then convert into a vector or a list. I hope that was clear. Usually don't allow to add a element in between. Again, if it allows to add an element in between, internally it will take care of restructuring the whole vector. It will be very inefficient. That's the reason they usually don't provide an API to do that. I hope, Karunakar, that was clear. Okay. So here, as I was saying, accessing the 100th element, accessing the 100th element, we access the third element by index because it is indexed. Contiguous location, contiguous memory location, and we get the reference to our next 32 elements, the fourth 32 elements. We'll get the reference, and to that reference, again we add a indexed fourth index of that reference, we'll get the 100th element. So to access 100th element, we had to traverse from only one reference. Now suppose I want to access 80th element. Probably the 80th element may be somewhere here. Again we have to traverse only one reference. Suppose I'm accessing some 50th element. 50th element may be somewhere here. So again, to access 50th element, I have to traverse only one reference. Rest all are constant time. So as a result, to access an element in vector is very efficient here. I meant to say the random access is very efficient in a vector. Linear lists are not good for random access. Vectors are good for random access because they are implemented in the form of a tree structure, which is very good for random access. So internally it is represented in this fashion, but we don't have to worry about how the internal representation works at all. We have to just use the API is very simple. Val, I will say vector is equal to just vector. Just like I created a list, I am creating a vector. The usage of the API is very simple. Even though the internals, we usually don't have to worry about the internals.
One,
Just, yeah.
uh, yeah, is the vector is equivalent to tuple in Python?
I am not sure. Is tuple? I
Because
think tuple is common in most of the language.
no, the tuple is immutable in Python. Those are also immutable. They're the same, similar to lists, but once created, they cannot be changed.
Yeah, yeah.
So those are.
Irrespective of whether it is a collection or a tuple, it will be immutable. It is not with respect to collections. Those are immutable, but I think the way we define tuple here, it's the same way it is in the Python also. If I say tuple in this fashion, it is some unordered collections. We don't say at a collection. Multiple elements can be kept there of different data type. I
Okay.
can say Scala, I can say 10.5, I can say true here.
Yeah.
So in Python also it should be the same because most of the
Yes.
languages treat tuple as a grouping of different data types, elements of different data types. But tuple is not a collection.
Tuple is not a
Tuple is
collection.
not a collection. Vector is a collection of the same data type. It has to be of
Okay.
the same data type. We can define for a different data type. I can say list. I can say mixed nums. I can say mixed nums. I will say 1 comma 2.5, or let's not say nums here. I will just say mixed. I will say what should be the thing here. I can do it in this fashion also, but it is of no use for us. What will be the data type of in this case now?
Boolean.
Yeah, as said by Naresh, that's true. It will be the common parent data type. Yeah, correct, Venkat. It will be the parent common parent data type. So here the mixed collection does not know what is the data type of individual data type. I mean individual elements. It doesn't know the data type of individual elements. It takes that every element is an any element. Every element. The same way if you give it in a tuple, if you see individual element data type is automatically inferred by the Scala compiler because it is meant for that. The tuple is meant for collecting of data of different data types, collecting of elements of different, but collection list, if we specify the same thing in a list or a vector or any collection, it will take the common parent data type. Now here is the question, but do we use such kind? No, I don't see such kind of list being used. Probably I haven't used anywhere. Probably somewhere they may use. Then they have to internally check each element. Internally check each element whether the first element is integer or any other element. Then only start. I haven't seen any such real-time use case. Usually collections will be of same data type. It will be same data type. Vector is also a collection just like a list, but the internal implementation is different. Internal implementation is different, which is good for random access, and vector list is for sequential access. That's the difference between list collection and a vector collection, and tuple is not a collection at all. It is not a collection. I hope Harsha that was clear. Yeah, as I was saying, also apply method. Apply method is internally called. There are many other methods on top of collections that could be used. Head, tail. Head will give the first element of the collection. Nums.head, if I do, it will give the first element of the collection. Tail will give the rest of the element of the collection, except the head. Except the head, it will give rest of the elements of the collection. Similarly, there are many other things. Nums.take of 2 will give the first two element of the collection. Similarly, if I say take right and 2, it will give the last two elements of the collection. It will give last two elements of the collection. Similarly, there is a drop. Drop will, it will drop the first two elements and it will give the rest of the elements. It will drop the first two elements and give the rest. Similarly, drop right, it will give the, it will drop the last two elements and it will give the rest of the elements. 5, 6, 7. So there are many other methods such that in a similar way, there are many other methods. If you see, as I was saying earlier, symbols are also used as methods on a object. Plus plus is actually a method. Plus plus colon is a method. Plus colon is a method. Forward slash colon is also a method. Forward slash colon backward slash. I haven't used those things. Probably I can check out what are those things. I haven't used all the methods in this. Probably few of the methods I have used. We can talk about those methods. If you want to know any specific methods, let me know. I can check on those things. So usually we use a collection inside a for loop in this fashion.
Y- Yeah, Pramod, it's again same question.
Yeah.
So if I want to know about any particular method,
Okay.
is there any document where I can go through what is
Uh,
the use and how I can?
no, I think it will be in the main source is Stack Overflow. Other than that is the code itself. Other than that, it's the code itself. When you say, I will just say here, I'll just say val nums equal to list of. It is only that when you face a problem that you look for a particular API. And I will say nums dot. When you say nums dot, you should get all these APIs. So using these whatever APIs, you just click on that. For each is there, drop is there. So whichever you want, you click on that and use that. Yeah, as Scala official document, you can also check there, but I don't think so. It will be off. You can just get one liner or two liner. It will be, it's just like earlier if you see man pages for a particular API in Linux, similar to that you will have. Just you can Google it once. Stack Overflow are the best solutions. You will see Stack Overflow. Sometimes they have given. Otherwise, just go to reverse method. I will just say I'll take one of the head. I will just say head here. Just press the control key and hover on that. You should get the head here. The definition, it returns something. Okay, even here it is not there. Till we have a list. Okay, this is an abstract class. Here also not much things are there. Probably you can get take right that we discussed. It internally loops through that and gets the object, gets the element. Either you go through this code, Stack Overflow, and as given by Ram, yeah, this is the official document of Scala. Scala official document, you may get something there. But usually I haven't gone through Scala official document. I find it a bit incomplete. Otherwise, you have to go through like code here. These are all the APIs on that collection. So you can go through the code and check what is happening here. Drop here, span is there, reverse is here, hold right to stream. Lot of other things are there here. Yeah. So where were we? Yeah, as I was saying, usually collections we loop on a collection. We go through each element of a collection and we do something on each element of the collection. So how do we do it? Probably we can use the for comprehension or for expression. We usually try to use a for expression on a collection. So I can use a collection. If you see earlier case also, when we had defined I and we had defined 1 to 7, we saw that 1 to 7 actually created a collection, a range collection, where we incremented from 1 to 7, where the collection elements were assigned to I and it started moving. We did whatever we wanted to do, like we did println of I. So actually 1 to 7 is a range collection, but we can also use our list collection as well. I can also use our list collection as well. Similarly, I can use the collection of strings as well. It is just a collection that we are using, and each element of the collection will be iterated and assigned to I, and whatever we want inside here we can do it. This is the body of the for expression. But instead of doing this, the Scala, what it has given here is they have given a for kind of a method itself to that collection. There is a for method. Similar to for, there is a method called for each. There is a method called for each here. Suppose I have a list nums. We know that nums is a list of 1, 2, 5, 6, 7, 8 and 9. I will say nums equal to this. On this method itself we have a, on this collection itself we have a for each method. We have a for each method. So what does that for each method looks like? Again, for each is a higher order function. It is a higher order function means it takes a function of some data type and returns unit. This is the data signature of for each higher order function. It takes a function and that function takes some parameter of any data type. A means it could be integer, it's a type parameter. A is a type parameter, where the type could be integer or string or a double or a boolean or a character or a user defined object, anything. So the reason for this is we can have a collection of integers, we can have a collection of string, So the for each method should work for either integer or a string or anything. So if you see here, what it takes some data, that function, and it returns a unit, or you can say the return data type is unit. What do we mean by return data type as unit? Unit means just like void. We had already discussed it. Unit is just like void. It means we do not return anything. We do not return anything in the for each. If we do not return anything in for each, what we mean by for each now? For each is used to do some mutability. It is used to do some write operation or update, or modify operation. Because it does not return anything, obviously it has to write something, update something, or modify something. So for each is a mutability function, mutability method on top of a collection, but it is a higher order function. So how we can use it? If you see, it takes some data type, that function that we are passing to this, it should say take some data type, and it should return a unit. Is there any function that takes some data type and returns a unit? Did we see any such function? We saw that we can use println. We saw that println is a statement that takes some data type and it does not return anything, or it means the return data type is unit. So obviously, so what is the parameter to this println? What is the parameter to this println? The parameter is each element from this collection. Each element from this collection. That's the reason the data type is of a type parameters. In this case, it took element as an integer. A was an integer. Similarly, I can execute the same expression for colors. So in that case, string was the type parameter. String was the type parameter for this. So we are not returning anything. Actually, println is updating a console. It is writing on the console. That's what we are modifying here. We are writing on the console. So for each is usually used to update something or modify something, and it is one of the higher order functions available on the collection. Instead of using a separate for expression, we can use the for each on the collection itself. So I hope you got the idea behind for each higher order function. For each higher order function. Any questions still here? Okay, if there are no questions, we'll move on to the next higher order functions. If you see, we are going one step by step. We learned functions initially, then we learned higher order functions, then we learned collections. Now we are learning how a higher order function is applied on a collection. Because in Spark, we will be dealing with the same thing, applying higher order function on a collection. There is one more higher order function called a map higher order function. There is a map higher order function. So let's say what is the data type of that map higher order function. We have a map higher order function that takes a function that takes some data and it returns some other data, or it could be of the same data type. Here it is only difference is in for each and map. Here it is returning a unit, hence it becomes a mutability method. but this does not return anything. I mean, it returns something. Hence, we are doing a transformation here. We are doing a transformation. Each element of the collection is in the form of a data type. It is being each element is being transformed to some B data type. The data type is different here now. This is a very powerful concept. This is a very powerful concept. Yeah. So to explain this, let me take an example of colors. Let me take an example of colors. Now what I want is, I want the length of each element. I want the length of each element in the collection. So I can say, I can define a function length. I'll just define a function length to which I will pass a string, and yes dot length is the method I will be calling. So I will just define a simple function length. It takes a string and it returns the length of that string. There is a method available inside this for the string. It returns the length. If you see the data type, input data type is a string, return data type is an integer. So we are having two different data types here. Integer string is the input and return is the int, which matches the map higher order function. The function that we want to pass as a parameter, it matches that length function. Length function, because this could be string, this in this case a is string, b is a integer. Obviously I can pass that method as a, sorry, I can pass that function as a parameter to the map. So let's see what will happen here. Colors dot map, I will pass length as a parameter. Length as a parameter. So what it has given to me? It has transformed for, it took each element. To the length we are passing string. That string is nothing but each element of this collection. It takes each element and transformed into 4, the length of that, because we are computing the length of that string. Red we got 3, yellow we got 6, green we got 5. So this is what we call as a map higher order function, which is a very important concept here. Very important concept, because it is nothing but the transformations we are doing. So as I said, as question asked by Karunakar, can we update here? We are doing an update here, but it is a transformation here. Usually it will be used, immutability collections will be used for such kind of a transformation. What we had is here, we had blue, we had red, we had yellow, and we had green here. We had green here. So this we transformed into one more collection as 4, 3, 6 and 5. We transformed into one more collection. Each element was transformed from one format to another format based on f of x. Based on the f of x. Whatever logic we give here, based on that logic, each element of the collection is transformed to one more element. The destination collection is of, here it is a integer, here it is a string. It could be any data type. Not necessary it has to be a different data type. It could be the same data type also. So this is what we call as, it is again based on the mathematics set theory. If you see set theories, set is being transformed from, each element is transformed from one element to another element That concept itself is used for ETL processing, transforming the data from one form to another form. If you take a data set, from that data set, you want only certain things, or you want to change certain things for each element. Pass it to the map higher order function, loop it through each record, and transform to the destination based on the logic you give inside the f of x. So if you go back to our for with yield also did the same thing. Also did the same thing. For with yield. Internally, for with yield is being implemented using the map higher order function internally. That's the reason for expression in Scala is a bit different from for expression in other programming languages. That's the reason here. I hope the map transformation was clear here. It is all about transforming the data from one form to another form. If you go back to map reduce also, it's the same thing. If you write a map reduce application, in the mapper interface we have a map class. It also takes key comma value. It takes some key comma value. We do some modification. We do some apply logic, and we output some key, I will say key x, and some key y. Sorry, value y. Some key and some value. Some value here. It will output some key and some value. It means that we are transforming this data, the input data, to some other data. We are transforming this data to some other data. The same thing we are doing here. The transformation is being done from one format to another format. That is all about the map transformation. So we can do any kind of transformation using the map higher order function. It will loop through all the records and it will convert. Suppose if again, we know that we can use the shortcuts here. We know that I can directly use s dot length. Sorry, my mistakes. I can directly use shortcuts here. I can directly get rid of this thing as well, and I can just say underscore length. So usually most of the time you will see the code in this fashion. You will see the code in this fashion. We have discussed it yesterday. Similarly, now if I want to transform each element of the collection to the first character of the collection, I want to transform and get only the first character of each element. That is B, R, Y, and green. We know that underscore is the parameter that we are passing to the function of the higher order function. Underscore, which is nothing but these elements. Underscore is a string. Underscore of 0 will give the first element of the collection. Hence we are transforming each element of the collection to the first element of the collection. If you see here, it is a character. It is a collection of list has been transformed to collection of characters. So you can do any kind of such functions, any kind of logic can we give, and we can transform the data to anything. I can transfer the data to anything. I hope the map higher order function was clear. Any questions on map higher order function? Yeah, if there are, okay, no questions. If there are no questions, we'll move ahead with and look some more higher order functions. Like we have a map higher order function, there is also a filter higher order function. What does that filter higher order function do? and what is the signature of filter higher order function is. Again, filter is a higher order function. Yeah, I will send some exercise on map higher order function exercise. I will send some exercise examples that you can try out at your place. I will send it. Similarly, I have filter higher order function. Filter is also a higher order function. It means it takes a function of against type parameter, because filter will also apply on a collection. All these things apply on a collection, and that collection could be of any data type. Hence we are using a type parameters, and it returns a boolean. The function that we are passing should return a boolean. It can take any parameter, and but it should return a boolean. If the condition is true, if the condition is true, it will return. It could be like this, right? The filter could be in this. The definition of the filter could be in this fashion. Whenever we call some x here, whenever we call this x here, it can return a true. F of x is called, it can return a true. It will be collected in a destination collection. Else it will be dropped. That element will be dropped. Whenever we call this function, if this function returns true, because it has to return a true or false. Whatever function we pass as a parameter, that function has to return true or false. If it returns true, it will be collected inside the destination collection, otherwise it will be dropped here. If it returns false, it will be dropped. That element will be dropped. So we can check in this fashion. I can say nums dot filter. I can say take each element and check whether it is greater than 7, greater than 7 or greater than 6, I would say. So if you see this method, the greater than method, it returns a boolean. So for whichever elements it is true, that element will be collected in the destination collection. It will be collected in the destination collection. 7 is greater than 6, 8 is greater than 6, 9 is greater than 6. So it is just like this. We have defined like greater than method, and we are passing and we are passing x integer, and we are saying that if x is greater than 6, return x. Sorry, just say x. If don't use the if condition, this is the condition we are giving, greater than. So we are just passing that function here, greater. It is just like the same thing. Instead of that, I have directly given the shortcut one. I have directly given the shortcut one. So we are just passing each element of the collection to this greater method and we are checking whether it is greater than 6. It will result only a whichever is greater than 6 only will get those collections. So if we compare it with map, the number of elements in map, if there are n elements here, here also there will be n elements. But in filter, The destination may have less than or greater than, less than or equal to n because some elements will be filtered. Some elements will be filtered. So again, it is kind of used in the transformations. If you have a large data set and if you have to filter out the records which are malformed records or error records. So you can go through each record, give a filter, write a filter function like we wrote a greater method, greater function, write your own logic of the filter where you want to discard the error records and pass that function as a parameter to the filter higher order function so that we can discard the malformed records from a bigger data set. So this is how we will be using filter higher order function. I hope the filter higher order function was also clear here. The data type, the signature, and how it is being used. How it is being used. Any questions here on for each higher order function, map higher order function, filter higher order function? So we can chain these, since these are pure functions, it means it returns something. We can chain these functions together. I can change these functions together. I can say uh, colors dot map. I transform each element of the collection to its size. It will return a collection again. We know that it will return a collection. On that collection, I can apply the filter. I can apply the filter and check which all the elements whose size is greater than 4. Greater than 4. So this way, I can chain the things together. On the collection, we only got 6 and 5. 5 is for green, 6 is for yellow. Which is pure function here. These are the pure functions. Was that a question, Ram, or you are just saying that? Pure functions means it returns something. I just added a pure there where we return something. Returning a value is nothing but pure. We don't do any side effects. Sometimes modifying, if you will hear that modifying also is termed as side effects. This function does a side effect means it is modifying something or updating something or writing something. If you are not doing any side effects, it means it is called as a pure. These are all jargons, pure functions, everything related to mutability and immutability. You modify something and you don't modify something. Since we are not modifying, it returns the data type. It returns a collection. On that collection, again, we are using the filter collection. We are again using the filter collection. There is one more higher order function I wanted to discuss. Let me put into the next class because it requires some extra, a bit extra time. That is what we call as a reduce higher order function. A reduce higher order function. Again, it takes a function. In this case, it takes 2 parameters and returns a one more parameter. So this is one more higher order function that is available in on collections reduce. Probably we'll do it tomorrow. Let's not, because it takes at least some 10 minutes to digest this concept of reduce. I hope till here the things were clear on how we apply higher order functions on collections. I hope we understood the collections. What are collections? and we saw how higher order functions are applied on the collections. Any questions? Any questions here? So if there are no questions, we will wind up.
Pramod?
Yeah, yeah, Harsha.
Yeah, this map function, no, I'm just comparing, like we have map reduce, right,
Right,
classes
right,
in,
right,
so this performs same function as that, like,
right.
uh,
That's
right?
absolutely correct. It is the same thing. In MapReduce also we have the map, but what
Yeah,
we have to do is we have to implement that map function from the mapper interface.
yeah, mapper class, yeah.
Mapper interface is there. From there you have to implement that map. All those things has to be done. But here we have to just use that map higher order function. And the same function is being used in Spark also. They
Okay,
have taken the same map higher order function from Scala and they have implemented it for Spark collection. Spark
okay,
already is also just like a collection, as I said. It is the same thing.
okay.
Yeah. Anybody else? Any other question? Right, right. Just I will do one thing. I will send some. What is that? Send some exercises. Probably it will be helpful to execute those things. Yeah. Thank you, Venkat. Sure. We will wind up here, and again we will meet tomorrow. Yeah, sure. I know that. I have sent you a email. Oh, for the exercises, yeah, I will be sending to that same email ID. Yeah, everybody have a nice day, and others have a good night.
Take care. Thank you. Have a good day.
Bye. Bye.